Okay, so we'll continue with the discussion of the WCF services. But before we continue, we'll quickly recap what we have learned so far. So what is endpoint? For the WCF service, how do we define the endpoint? Correct, it is ABC, and A is for address, binding, and contract. Right, correct. So every WCF service must have how many endpoints? How many minimum endpoints are required? Correct. At least one endpoint is required because without endpoint, the client cannot communicate with the service, right? And how to get the metadata from the service? Okay, for that WSDL file is required, but what is the mechanism to fetch this WSDL file? Mm, okay, which protocol is used to fetch the metadata? Yes, correct. It is MAX protocol. Okay, so to fetch the metadata, there is a MAX protocol, which stands for metadata exchange, right? So usually we will also have one more endpoint other than the communication endpoint. So every web service will have at least two endpoint, in the sense that one is for communication and another for exchanging the metadata with the client. So right now we are assuming there is no separate broker component in our architecture, so that this metadata itself lies with the service itself, right? So web service will also have the metadata. It will also have the communication endpoint, right? So the service will usually have at least two endpoint. One is max endpoint, another is communication endpoint. And other than max, you can also use the HTTP protocol to download the WSDL file. So it depends upon the client or how the service is exposing the metadata. You can download the WSDL file through the simple URL, or you can use the MAX protocol to download the metadata, right? Okay. So these are the important part of the WCF service. Okay. Can you recall what are the different types of contracts available in WCF? Correct. Service contract, data contract, and message contract, right? So there are mainly three types of contract. What is the use of service contract? Correct. It defines the behavior, or mainly the functionality implemented by the service. Okay, what is the functionality offered by the service is defined using the service contract. When should we use data contract? Right, if the operations uses non-primitive or composite type, in that case we have to use the data contract. And what is the use case for the message contract? Correct. If we require to have the how to send the data, which data should become part of the SOAP message body, or should we pass it as part of the header, then we should use the message contract. Okay. Okay, fine. So let's continue with the applications that you have already seen during the lab. And if you have any doubt, you can ask me during while discussing the creation of the web service. What are the steps? Why this step is required? And what are the outcomes of that particular steps? So we'll gradually will go into the more details of services and how it is created and how to write the client for the service and so forth. So just a minute. Okay. So you've already seen that in the lab how to create the web service using the default template available as part of the Visual Studio. So you have to select the WCF service library as the type of the new project while you create a new project inside your Visual Studio IDE. When you create this WCF library project, it will by default create a boilerplate code for basic web service with an interface and a class implementing that interface. So you can see in the diagram, these are the boilerplate code generated by the WCF service library template. And this interface will contain the service contract, while this service one class will implement the operations available in that interface. So this is the interface file. You can see that it contains an interface iService1, and there are two methods inside this iService1: get data and get data using data contract. So you can see that get data methods takes integer value as the input parameter and it returns the string. So now this operation can be invoked by the client, and that operation will be executed on the service side. Whatever the output here, the string data will be returned from the service back to the client. So few more point regarding this interface. We are annotating this interface with an attribute called service contract. So it is required because whenever we want to tell it to the client that these are the operations supported by this service, so all those operations must be part of this service contract. Additionally, all the operation must also be annotated with the attribute operation contract. Otherwise, if we do not annotate an attribute with the operation contract, those operations are not visible to the outside world. They are not exposed to the outside world. That means the client cannot consume those, they cannot invoke those operations. Okay. So the example is in the class, in a typical class, we have the private method and public method. So private method are meant to be executed or invoked from within the class, while the public method can be invoked via the instance of the class. Right. So in case if you want some method not to be exposed to the outside world, you can simply remove this annotation operation contract. And you can see the another operation called get data using data contract, which takes the composite data type, so custom data type. So for that we are using the data contract. So you can see the class composite type class is annotated with the data contract, and all the properties are annotated with the data member attribute. So that way we can say that this is the data contract because this is the user defined type. So by default, this WCF framework will be able to convert this primitive type to the XML automatically. But in case if you are using custom type, we have to explicitly mention that we are using data contract because this is custom type. So for that, it will whenever we annotate property with the data member attribute, then it will be converting it to the appropriate schema data type. So is it clear this code? What is the purpose of interface, and what is the need of operation contract? What is the need of data contract, and why should we annotate the property with the data member attribute? Any doubt in this file? Interface and class composite type. Yeah, correct. Data contract is to be defined on the class which we passed as an argument to the operation or maybe as a return type. So see that there are two operations. One is get data, another is get data using data contract. So the input and output parameter for the second operations are composite type or custom class. So if the operation uses them, then we require data contract. Otherwise, there is no need to use the data contract if your parameters are primitive type. But in real life situation, normally we need to deal with the objects. This is similar to what we use, we call it as a model in our MVC pattern. Okay, model is nothing but the data that we are passing from backend to front end, and then it would be handled by the front end. So if you remember that in our AT subject, we are using JSON data. Okay, so here in SOAP message, these are converted to XML. Okay, and XSD, that is schema data types, are used for representing this data. So see that this is we are writing web service in C#, and our client may be written in Java. So it is not necessary that the integer value in C# is same as it is represented similarly in the integer value of Java. So there is a problem of type incompatibility because we are sending an integer value from C# and we are reading the integer value in Java. So both are incompatible type. To resolve this issue, there is an intermediate code called XML is generated. So internally what happens, this integer value will be converted to the string through the process called serialization. Hope that all of you know this process, serialization. Yeah, everybody answering yes, right. So this serialization process will convert this integer value to the XML, and then on the server side or maybe on the client side, whenever it is receiving the data in XML, it will be converted back to the native type. So if my client is Java, then it will be converted to integer value of Java, integer representation in Java. So that process is called deserialization, and in the literature you will find out two more terms. That process is also called as the marshalling and unmarshalling. So serialization term you are familiar with, but there are two more terms, marshalling and unmarshalling. I am just writing it down in the chat box. So in case if you read this term in the documentation, then you can understand what they mean, right? So And that's why this compatibility issue is handled by this XML or SOAP message, right? Within the SOAP message, the data is in the XML, and this conversion from native type to the XML is done automatically via some built-in classes. So if you go back to the previous slide, can you see a class called serialization? Okay, which is inside the system assembly system.runtime.serialization. So they are responsible for this conversion, right? There is also a service model assembly where it contains all the WCF service related objects, right? Yeah. So let's move on to that next slide. So this we already seen. This endpoint is consisting of address binding and contract, and additionally they also specify the behavior. Okay. Yeah. So this is the service one class, which is implementing the interface iService one. Both the methods are implemented over here. So the first method right now we are focusing, which will take the integer and return a string value. So it will return a string called you entered, whatever the number which has been entered by the client, right? So this is the service implementation. And there is also corresponding get data using data contract, which takes the composite type and it processes on that, and it will returns it modifies the input object and returns the updated object. So if you look at if you go to the previous composite type, which is a data contract, you can see that it has two property, boolean value and string value. So boolean value is initialized to true and string value is initialized to hello. And here within this implementation, it is checking that whether the object is null or not. And based on the boolean value, if it is true, then it will it will concatenate the string value with the keyword suffix, okay, or literal suffix, and it returns the updated composite type object. So is it clear this implementation? You can easily change this implementation as per your need, and you can define multiple contract as per your need. Okay, so no doubt, let's move on to the next slide. And it will also generate this file called app.config. Okay, so we are not writing this file, it is automatically generated. But if you want to make changes, we can also make change in this file. This configuration file defines several things like related with services, how many services are there. Okay, for every service, what is its name, what are the different endpoints. So you can see that mainly here there is one endpoint called one endpoint with the address equal to empty. So why the address part is empty? Can we have a web service without any address? Why the address part is empty? Right, because the base address is defined. So actually this address part as part of the endpoint is relative address. Okay. So whatever we define as part of the address will be concatenated with the base address, and final address would be defined. So actually my address or the final address of that particular endpoint would be base address concatenated with the address that we specify as part of the endpoint. So the reason for defining the base address is that a web service can have multiple endpoints. Okay. So can you tell me the situation in which we require multiple endpoint? Right now there is only one endpoint, but think about the situation in which we might require to have multiple endpoints. Okay, so let me answer this question. That suppose I have two clients which uses my web service, but one of the client uses HTTP as the transport mechanism, and another client is uses TCP. To support both the client, I will create a web service with two endpoints. One is communicating over the HTTP protocol, and another is communicating over the TCP protocol. And the same service can be utilized by both the clients, right? Is it clear? One of the requirement, why do we require multiple endpoint? So we need not write the separate service. The same service can be reused. Only thing is required is creating multiple endpoint. And what we need to change, if you have two different endpoints, one uses HTTP and another is uses TCP, what kind of change is required? Correct, binding. Yeah. So here we are using basic HTTP binding, which uses HTTP protocol. But if you refer to the table which has been provided in the introduction chapter, which I already uploaded to the Google Classroom, you can download it and refer to that. The table inside that will list down the different bindings available, or otherwise you can refer to the official documentation from the Microsoft website, and then you can refer to the different binding types available. And there is a one of the binding called net TCP binding. Using that, we can have a separate endpoint which is used for TCP communication. And contract is iService one. So this is one of these endpoint. Next is max endpoint we are defining. Once again, we have ABC, address binding contract. Now we are using the max as an address. So the final address would be the URL, which is listed over here as a base address, concatenated with the string max will become the final endpoint for my metadata endpoint. Okay. Here the default binding for max endpoint is max HTTP binding, and it uses HTTP protocol to download the metadata, and the contract for that metadata exchange endpoint is iMetadata exchange. So these are default. We need not change it because this is the standard protocol. So we cannot change it. Only thing we can change is our own interface, our own contract, our own binding type, or our own address. So yeah. Now, one more thing is highlighted in the service behavior section, that here two attributes are set: HTTP get enabled equal to true and HTTPS get enabled equal to true. What does it mean? These are Boolean values, right? True or false. What is the purpose of those two values? Which protocol to use for what purpose? We are already using the binding, and binding will define what protocol to use. Then why we are additionally specifying these two attributes? Because the binding will define which protocol is used for communication: HTTP, TCP, pipe, UDP, or some other protocols. So does it mean that if we set both the value to false, the client cannot communicate with the service? Is it so? Okay. The reason for these two flag is to, can we download the metadata via the HTTP protocol or not? So if we set them to true, then we can download the metadata via HTTP protocol. If we set it to false, we cannot download it via HTTP protocol. And the reason to set them false is, so suppose I want to write the client code, but how the client will know that these are the operations supported by the web service? What is the protocol used? What is the behavior? How the client will know about all this information? All the information about web service, how the client will know? Correct, metadata. And those metadata are stored in which file? Okay, where this metadata are stored? Right, WSDL file. Okay, so suppose the client has downloaded WSDL and we are writing the client code. Okay, because now the client knows that get data method or add, subtract, multiply, divide, all the operations which are available as part of the web service, the client will know, and we can write down the client code to invoke those operations. But now suppose we disable this, but after that, do we require to fetch the metadata again before communication? We have already downloaded the metadata of the service, and as per that metadata, we know the functionality supported by the web service. We have written the code, but after that, do we require the metadata again? No, it is not required. So the idea is we can disable this. Okay, we can provide the metadata to the client and we can disable it so that now there is no need of metadata, so that other client or other application cannot use your service. Okay, other application cannot use your service because they will not know about the metadata, and if you do not know information about the metadata of the web service, we cannot design the client. Basically we cannot write the client code. So this is the reason that we have to disable it once the client has downloaded the metadata. Okay, so then only the communication endpoint will be there, but this max endpoint would be disabled. I hope that this is clear why these two flags are set and when to reset it. Okay. So now that is done because this is the default code generated, nothing to be done. We can simply run the project, and when we run the project, the Visual Studio will automatically host the web service, and it will also invoke a tool called WCF Test Client, through which we can test our web service. So there are three things. One of the thing is, first of all, first step is to write the web service. Second step is to host the web service, and third step is to write the client. So the client, and of course the client can be written only if we know the metadata. Okay, so now these three are written and the service is running on the host, then client can communicate with the web service. So basically here it uses the utility called WCF svc host.exe. This utility will host the web service. Then there is one more utility called WCF test client .exe that will be used to test our web service. So always when you write your web service, test it through the test client. Check that all the operations are working properly before you write the client code. And in the next lecture, we will look at how to host the web service. Like many web application, when you are developing web application, you need to deploy the web application on the server. Like IIS server, Tomcat, Apache, Glassfish. There are so many servers are available. You can host your web app. You create the WAR file, jar file, and deploy it on the server. Then you can start the instance, and then the client can access it, right, on the specified address. So similarly here, the steps for developing web service is to write down web service. Either write down the WSDL or you create an endpoint for max metadata exchange and then host it on some server. So there are different ways of hosting the web service. One is you can use the IIS server. Another is you can create a application. Inside that application, you can host it. So all of you know console application in .NET or in Java. So you can also host your web service in the console application. All of you know the Windows form-based application to develop the desktop application. Okay, so Windows form-based application can be used to develop the desktop application. There also you can deploy your or host your web service. So your web service can run inside that application. So usually it is called in-proc hosting. Okay, in-proc. And here proc stands for correct process. Any other usage of proc you might have heard? Yeah, in Linux, in fact, it is in fact entire file system. We call it as a proc file system, and it is a virtual file system. Unlike the other file system, which is stored in our hard disk, this is the virtual file system. It doesn't exist in the hard disk, and that's why it is called virtual file system. So proc file system. So in Linux, there is a concept of proc file system. So it stands for processes, because all the processes information you can gather it via the proc file system. Okay. Good that you know this. So we are running this web service, and let's go to the, yeah. So there are some cases that your web service will not run because your port number is disabled, or firewall is denying or restricting the usage of that particular port number. So in that case, you can use this command. You can run this command as an admin onto the command prompt to enable the HTTP protocol to use this particular port number. So right now the port number is 8010, but you can enable this port number for your application. And make sure that you are not using the port number which some application is already uses, right? Like your database application might be using some port number, or like Oracle, MySQL, and other applications might be already using some port number. So you have to use the other port number. So using a net sh command, maybe on the PowerShell or on the command prompt, but make sure that you run it as an admin, and then you fire this command on the command prompt. So basically, it will add one firewall rule which will enable this port number, any application that uses the port number. And for respective user, you write down the Windows username which you are uses to logging purpose. So anyway, I will be uploading this slide so you can also use it. So in case if your firewall is restricting the use of your application, then you can enable them via this command. Okay. So when you run it on the left hand side, it will show you the URL that it uses to download the config file, or rather metadata. Okay, so this is the config file that has been downloaded, and it will be rather created as per the metadata downloaded from the web service. And this WCF test client app will automatically create an endpoint to communicate with the web service. And it knows that there are two methods. One is get data, another is get data using data contract. Both the methods are available. You can see on the left hand side panel that both the operations are listed. If you click on one of them, it will basically display in the right hand side the number that you can enter. So basically it is asking for the get data. It takes one input parameter number. So you can simply write down the number and click on the invoke button, and it will return the response. Suppose I enter 1234 and press on the invoke button, then it will display a message that you entered 1234. So on the upper side there is a request, on the lower side it is a response. So request message will be created, sent to the service. Service will run that operation, get data, and it will return a response. That response is received by the client. So this is the test client, and it displays the output on our screen. So this is what we have already know, the implementation part. But now see that these two processes we are running on the same system, but not necessary. You can run it on any other system, maybe in the intranet or on the internet. If you are hosting it on the internet, you can invoke it from anywhere in the world where the internet is available, right? So this is how the web service can be invoked, right? And see that on the bottom there are two tab. One is formatted tab, another is XML tab. If you want to dig into the message details, then you can click on the XML part. It will show the request message and response message, the actual messages which are communicated between this test client and the web service. And as you know, these are the SOAP messages. On the upper side we have the request message, on the bottom side we have the response message. Let's look at them in the more details. So yeah, so you can see that There is a header part and there is a body part. Within the body part, there is an element called get data with the sub element value, which contains the number. So now you can see that here this is the actual XML which goes from client to service because it's a request message. So here the serialization process will take place. A number will be converted to the string, and on the service side it will be converted back from string to a number. Right now both are the same platform, but otherwise depending upon the target or web service, appropriate serialization and deserialization will convert it to the native type. And there is also a namespace is used called tempuri.org. So if you do not specify the namespace for our web service, then it will default to this name. But if there is a provision of specifying our own namespace. So we'll see that later on, that how to do that. Basically, you have to provide an attribute to the service contract. You have to provide the property of the service contract attribute, the namespace name. So right now we are going for the default value, and by default it will take on the value tempuri.org. And we have this response message. Again, you can see that header and body of the SOAP message. Header is empty. The body contains the get data response element with the sub element called get data result. The string which contains the concatenation of the word you entered and the number that we have typed in. So this is simple implementation. Yeah. Now, what next step we are going to do for this web service? We will create our own client. Okay. So suppose we'll start with the basic Windows form-based application or desktop client to consume the web service. So the steps are within the Solution Explorer. What you do, basically, you create a new project or add a new project within the same solution. Select the type of project to be the Windows form application. Give the appropriate name, say WCF client, and then it will create an empty window or empty form. Now for this client, I need to know the metadata of the web service. So for that, we can right click on the project name. There is in the context menu, there is a add option. Within add option, there is a option called service reference. So using that option, we can get the metadata of any web service. So if we click on that, it will show us a window in which we can type in the address of the MAX endpoint. So either you can copy paste, or there is another button called discover button. If you click on the discover button, it will automatically fetch this address because these are part of our solution. Otherwise, you can copy paste that base address or MAX address, and then it will show you that service is found. And then you can give the new namespace name, and it will create the a class which can be used to invoke the web service. Okay, so within this given namespace, it will create a client class through which you can invoke the web service. And when you do this, it will automatically generate the app config file for the client. So this file contains the similar behavior, like we are defining this client. We are also defining the same binding which are used by the service, and the client also has the endpoint having ABC, address binding, and contract. But now these are auto-generated code. Don't try to write this code yourself, because when you do this step of add service reference, it will automatically download the metadata from the web service, and from that it will be able to generate this app config file. So is it clear this step, why we are doing add service reference? And you can see this code is also automatically generated. From that it has found the address part automatically, binding is also found automatically, then contract is also known, because only contract will be exposed, actual implementation will not be exposed to the through the WSDL, right? And okay, and so this is what are the classes that I was talking about that will help you in serialization process. And it will also create a class called service one client, through which we can invoke the operations of the web service. And within the project, it will also create the WSDL file service.wsdl. Okay. So now next step is to design the GUI for my client. So on the left hand side, you will see the toolbox wherein you will find out the buttons, labels, text box, right? You can just drag and drop onto this Windows form, and then you can create the nice GUI. So here a text box is added, label and button is added. No, usually we should use the different namespace name. We should not use the same namespace name. And I think just a minute. Are you talking about this? Just yeah. So this is the namespace name for the client, and usually for every different project we should keep the separate different namespace name, so there is no conflict. Yeah. So this is the design for the client. We have text box, label, and button. So the idea is to this text box. Through this text box, user can enter the number, and when the user clicks on the button, it will invoke an operation get data. That get data should be run by the service will produce the output that will be sent back to the client, and the client, that response will be shown as the labels text value. So if you click on this button, double click on this button, it will automatically generate the code for button click event handling. Okay. So this code is important, though it is very short and sweet. But see the code, just look at the code. It is a button click event handler. And within that, we are creating an instance of service one client. So see that this class is containing methods get data and get data using data contract. Right now we are invoking only get data method, but this class is only a proxy class. That means it doesn't contain the implementation. It is only the template. It does not contain the actual implementation. So when we call or invoke that operation get data, so what we are doing, we are getting the text box value, we are converting into the integer, and we are invoking that function or that method get data. So inside that, it will establish a connection with the web service. The message will be transmitted. SOAP message will be transmitted from client to web service. There it will be received by the service. It will do the deserialization. There it will convert this into the number, back to the number. It will produce the string will be sent back as a response message that will be received by the client, and client will convert it to back to the string format, and it will, right now we are displaying it as the label value. So is this flow clear, what is going on? Because these are generated code, and behind the scene this many these things will happen. This will be done transparently, and actual code will run on the service side. Only your invocation will take place, but the body of the operation will be running on the service side. And now we need to run the our client. So it will display a form with the text, label and button. If we enter the value and click on the button, we'll get the response that you entered 34. So this is how you can develop the client, and then you can consume the web service. Any doubt so far? And this WCF framework has the many classes which will help in performing this communication automatically. We have to simply select the appropriate binding, and for the client, like we have seen, by simply adding the service reference, it will automatically fetch the metadata, and based on the metadata it will be able to produce the service client, which is a class which will have all the template method. So internally it will establish having some method which will establish the communication channel between the client and the service, and then over that channel communication will take place. All the serialization code, everything is done automatically. That means it will produce the desired code. Okay, and simply we have to use it, because the rest of the thing is automatically generated by the this Visual Studio, and this framework having many classes. The system.service model assembly has many classes for doing this communication. Similarly, you can develop the web client. So I am giving you as an exercise, and I'm also having the code for the same. You develop the web application, ASP.NET web application, develop this web form, provide the text box, label and button, double click the button and write down the code. Before writing the code, you need to add service reference, and then similar code, and you can run, and from the web you can test it that web service is running or not, and you are getting the desired output. Okay, fine. So at this point we'll stop, and if you have any doubt you can ask me before we end the session.
Sir, in in CS file, we have to write code our own, or it is auto generated.
CS file we have to write our own code, because in both the service and in client, because service will generate interface only. The CS code we have to write, and
No, sir, in client.
in client we have to write our own code. That
So-
service client class will automatically generated, but we have to use it as per our need. Should I set that slide where?
Yes, sir.
Yeah. Just a minute. Okay, I will tell you which slide, the slide which we need to write ourselves. Yeah, this code we have to write ourselves. Okay, let us go back to the Windows form. Yeah, so this is our form with text box, label and button. Double click on the button and it will generate the event handler. It will button click event, and within that we need to write down these two lines. Create an instance of service client, and invoke the method get data.
Okay, sir, clear.
Only 2 lines we need to write.
Yes, yes.
And this service one client is automatically generated. So we need not define this class ourselves. Okay, fine. You try to write down the client yourself and verify that the code is working. Otherwise, we can discuss it in the next lecture if it is not working. During the next lecture, you can ask the question. Okay, fine. Thank you.